Hello class, today we're going to be going over Module 9 homework, and Module 9 is on logistic functions. And a logistic function is a function that models growth, but it models it a little more accurately than exponential growth. And that is because logistic growth takes into account an upper bound, an upper limit, if you will. Because if you think about growth exponentially, after a while, the rate of change increases very, very rapidly and tends towards infinity. But that is not the case in real-world situations. There is always going to be some sort of, well, almost always going to be some sort of upper bound where we can't grow any further. And that's what logistic growth models. So let's look at the homework. The following function represents the amount of yeast biomass after T hours in a culture. So we have our function A of T, and A, according to the model, what is the amount of biomass rounded to the nearest hundredth after 8 hours? Well, all we need to do is plug in 8 in for T. We're just plugging it in. And I plugged into my calculator. And after plugging it in, I got 348.872. So that would be the biomass after 8 hours. Or I guess I should say A of 8 equals 348.872. Looking at B, according to the model, what is the maximum biomass for the culture? Well, for that we just need to know what this function is saying, and the number on top is going to be our upper limit. So the maximum biomass for the culture is going to be 663, meaning that this culture will never grow greater than 663. And then part C, use a graphing calculator or Desmos to graph the function. Estimate the point of inflection and explain its meaning in the context of the problem. So I went ahead and I graphed it onto Desmos, and the point of inflection is in the center here of the growth, and the point of inflection is where the rate of change is greatest, where it's growing quickest. So kind of eyeballing it, it looks like a little less than 8. I would say about 7.75. And our Y value would be around, probably 320 would be a safe bet. So we could say the point of inflection, if we were to estimate it, would be 7.75, 320. And what is the meaning in context of this problem? Well, at 7.75 hours, the biomass is 320. And we could say this is the point where the rate of change is greatest. And that is Module 9 homework. So that's all I have for you all today. Until next week, have a good day.